So here's a simple web application to compare the performance of two neural networks. Both the neural networks are going to be trained with the same data set and are going to try to compete to predict better than the other. The data set is basically a large collection of almost handwritten numbers between 0 and 9, and that's what the models will try to predict better than the other. We will train the models, and over time we'll try to see how long does it take which model to reach what kind of accuracy. So for the first model, I can try to set a small number of channels in the first and second convolution layers, and I'll keep the kernel size as well to 3 cross 3. For the second model, I'll try to make it quote unquote bigger, where I'll give it 64 channels in the first convolution layer, 128 channels in the second, and almost a large kernel size, 7 cross 7. I'll use the Adam optimizer for the first one and the SGD optimizer for the second one. These are basically the optimizers which take the gradients calculated by the loss function and apply them back to the original parameters, trying to update the neural network or the model during the course of the training. And different optimizers will update the initial parameters differently. And for the first model, I'll give it a large batch size and small number of epochs to work with. The batch size is basically what kind of chunks of the training data you take in a single pass. And the epochs is the number of times you pass through the entire data set. And and for this, I'll give it a small step and a long number of epochs to work with. And yeah, now we can start training. So as the application starts, takes a minute, and we start seeing the performance of the first model. You see the loss function is going down. Accuracy is almost in range of 99% already in 5 epochs or 5 passings through the data set. The second model, which starts with a large number of or higher size of channels and higher kernel size, etc. You see it starts with a higher loss function and a lower accuracy, but we've given it more time to run, a more number of passes through the data set, and it's also, you can see it's a bit slower also. So while it still runs, you can see it has finished 9 runs of the data set, 10, and it's still at only about 98% accuracy, while the first model also reached 99% accuracy within the first 5 runs through the data set. And we can see we're almost finishing the training, and the loss function for loss value for the first model was already as low as 2.6. I will quickly stop the app from refreshing. So we see it was almost 2.6 within 5 runs through the data set, whereas the larger model, in spite of running slowly, it still is at a loss of 4.2 at the 4.3 at the end of 15 runs through the data set. Both the models kind of got sample predictions correctly. As you see here, the almost handwritten digits and the model 1 and 2 are both have correctly predicted it to be 9. And so on. This is 0, 4. Both the models got this wrong. This was supposed to be 2, but both the models thought it was 7, which is fine. Hence, only 99% accuracy. And I think the key point here is that giving larger channels and kernel sizes doesn't necessarily mean the models will perform better. And yeah, that was a short demonstration. Yeah.